Okay, hello everybody. I'm hoping that I can get through this video in less than 25 minutes because I need to go get my son and that's when I need to leave. So hopefully, or actually no, guaranteed the video will be less than 25 minutes. How much less than that, I don't know. All right, so on this video, we're going to go through all the different properties of exponents. And I really hope you guys watch this because I'm going to give you the answers to like 6 or 7 or 8 problems on the worksheet for tomorrow. So as we're going through this and doing the examples, go ahead and write down those problems. Make sure you write down the problem numbers so you don't have to search for them all over the worksheet. All right, so let's look at this. We have lots of different properties: the product of a power, quotient of a power of a power, one-to-one properties, reciprocals of a power, rational power, and distributive properties of exponents. Okay, so all of these properties you've seen before, or at least you should have seen before in Algebra 1, not Algebra 1, sorry, mostly in Algebra 2. You might have covered some of them in Algebra 1. I'm going to take these a couple of properties at a time and just kind of go over them. So in this case, we have the product power and the power of a power. Okay, so these are two very similar properties, but they have some distinct differences. So if we have the two terms with the base number the same, and we're multiplying them together, then whatever your exponents are, you can just add them. So notice how we combine this. So on the worksheet for tomorrow, problem number 20, you're going to have x to the 1/2 power times x to the 4th power. That's a 4 there. Okay, and then the answer is going to be x to the 9/2 power. And the process that they use to get that is they take, because you have the same bases, you just have base of x times, or sorry, raised to the power of 1/2 plus 4. Okay, and then I'm not going to go through the whole process of combining or getting common denominators and everything. If you're not sure how to do this, plug it into your calculator and just get a fraction. But basically, the 4 would become 8 over 2 plus 1/2. Okay, and that's how we get the fraction 9 over 2 as your exponent. Okay. And so that's kind of just one example of how the product of a power works. Okay, now if you have a power of a power, so notice here you don't have two base terms up here like you do here. Here you have a base number raised to a power, and then that is also raised to a power. So when you have this type of situation, it's just whatever your base number is here, raised to the power of these two exponents multiplied together. So again, very similar. Problem number 19, you would just have x times 1/2, or raised to the power of 1/2 times 4. Okay, and then 4 divided by 2 is basically what you're doing, and that's going to give you x squared. Okay, so these are the answers to these problems. I do want you to show your work on your worksheet. So make sure you know how to solve those answers, or how do you get those answers. Now let's look at the quotient of a power and rational power. Okay, here you're dividing. You have a division here, and it's the base numbers that are being divided. And then for rational power, notice the fraction is in the exponent, not the actual base number. Okay, so if you have a division here, what you'll do with the exponents is just subtract them. So in this case, we would have x raised to the 4 minus 1/2. Okay, and then when you get common denominators, you would have 8 over 2 minus 1/2. And when you're subtracting fractions, you subtract the numerators, leave the denominators alone, and that's how we get this fraction in our exponent of 7 over 2. Okay, and then for rational power, here your exponent has a fraction in it. And notice that this is problem 8 on the worksheet you're going to do tomorrow. Notice there's a decimal here. Well, 0.8 is equal to 8 over 10. It's supposed to be an 8. There we go, 8 over 10. And you can reduce that to the fraction of 4 over 5. Okay, so what we actually have is this x raised to the 4/5 power. Well, whenever you have that case, what you have is a root and a power at the same time. So here, notice our power, or in our exponent, the denominator is your root. Okay, see how they move that to the 5th root of x to the 4th power. And so whatever's in your numerator, that's going to remain your power. Whatever's in the denominator becomes your root. Okay, I know most of you have probably only seen like square root, but you can have a cube root where you have like a 3 here. So I could do like the cube root of x or anything like that. You can have any number here. And the way you would say it is whatever that number is, root. So or like the 5th root here and 3rd root here. All right, so let me get rid of that. All right, so that's for problem number 8, and this is an example of the rational power and the quotient power. Please do not confuse these. Don't get them mixed up, okay? In your notes, you're going to have all these properties of exponents, so please know exactly where they are in your notes and know how to use them. All right, the reciprocal of a power. So if you have a exponent raised to a negative, or sorry, if you have a base number raised to a negative exponent, all you do is you set up a reciprocal. So you just put a 1 in the numerator divided by whatever your base number is raised to the positive exponent. See how we lose that negative sign there? Now in this case we have the 0.8 again, and we know that from previous problems that 0.8 was equal to the fraction 4 over 5. Okay, we just saw that. And then notice we have a negative here. So notice, let's go back to this one. We have the 5th root of x to the 4th power because of the fraction. Okay, so 5th root of x over 4 power. That takes care of the fraction, but then because of the negative sign, we just set it up as a ratio, or the reciprocal, sorry. So in this case, we're dealing with 2 different fractions. We have the fraction in the exponent, and then because of the negative, you're going to set up your problem as a fraction as well. Man, we have just fractions all over the place. All right, so moving on. The distributive properties of exponents. Okay, so this can take a couple different forms. So if you have a root and you're multiplying under the root, you can separate those, where you see how we just took the g and we have g root of a times g root of b. Okay, you can separate those, and you can do the same thing even if you're dividing in the root. Okay, you can separate them. So let's look at problem 25. This is the answer. Let's see how we got this answer. It's going to take a lot of work to get there, and we just need to use all of our properties that we've covered so far. So in the first place, let's take care of this root. I can rewrite this root as x, 1 over 2. Okay, so notice I don't have a exponent here. If you don't have the exponent, it's 1. 1 is your exponent, okay? And notice we don't have a number here. Well, we know because the square root is so common, if there's no number here, then the number is a 2, okay? So let me get rid of that one. All right, so we have x to the 1/2 power times y to the 3 over 2 power. The reason why we have a 3 over 2 is because of this power here. Okay, and then we also have this stuff here. Well, x to the 1 power is going to be multiplied by x to the 1/2 power, and y to the 3 over 2 power is going to be multiplied by y squared. So y squared there. Okay, now if you recall, when you are multiplying these, you would end up adding them. So I have the same bases, and I'm just going to add my exponents together. So 1 plus 1/2 here, and then the y as well. We're multiplying the x and the y together. Y, and that's going to be 3/2 plus 2 there. Okay, and which then this simplifies to 3/2, and this is going to simplify to 7/2. Hopefully most of you understand how that's possible. Okay, get your common denominators. 1 becomes 2/2. 1/2 is still 1/2. Combine this, you get 3/2. Okay, and so that's how we get this 3/2 here. And then right here, you have 3/2 plus 2 becomes 4/2. Now we have common denominators. Now we can add the numerators together. Okay, so that's how we get the 7/2 here. All right, so that one is problem number 25. Let's look at number 26. This time we have a fraction here. Sorry, just had to get a drink. All right, let's go ahead and split up this stuff in the parentheses. So our numerator is going to become x to the 2/3 power. And our denominator is going to become y to the 1/3 power. Man, my 2/3 power doesn't look very good. Let me rewrite that. So my numerator is x to the 2/3 power. There, that's better. And then my denominator, I have y to the 1/3 power. Okay? And remember, if I have a term in the denominator, I can go ahead and move it up into the numerator by making this exponent negative. So what I'm going to have that's just this stuff that's in parentheses is going to be x to the 2/3 power times y to the negative 1/3 power. Okay, and that will allow me to get this here out of the denominator. Okay, so now I want to go ahead and multiply these terms by it. So we're going to multiply the x to the 2/3 power by x squared, and we're going to multiply the y times the negative 1/3 power times y. And in this case, again, don't forget your exponent is 1. Okay, because you're multiplying these two together, you're going to add your exponents. So it would be x to the 2 plus 2/3, and then this will be y to the 1 minus 1/3. Notice what happened with our negative 1/3 here. Instead of adding these, you're subtracting them. Okay, and then here you get your common denominator. The 2 becomes 6/3, and then plus 2/3 allows you to get 8/3. That gives you 8/3, so that's how they got the exponent 8/3 from right here. Okay, and then and then for the 2/3, 1 minus 1/3 is just going to be 2/3. Your 1 becomes 3/3 minus 1/3 gives you 2/3. Okay, all right, let me see if I have any more. What do we have now? Okay. All right, so that's just some practice on your properties of exponents. Okay, you're going to need this information for class on Thursday. Okay, and then I just wanted to go over some exponential growth and decay stuff. So this will be very familiar with from our geometric sequences. Okay. And if we have an exponential function that's increasing or growing, then your b has to be greater than 1. Okay, and I'm just going to show you just a couple of graphs. So let's say we do y equals x to the, let's get a number greater than 1, let's say x squared. Whoops, what did I just do? Oh, dang it, I always forget that. Let's do doc b, I don't want that. Okay, let me move this so I can actually see it. Let me move that. Okay, notice my x is the exponent, not the base number. Okay, Let's go back to the graph. All right, so for now, I'm just going to ignore A for now. And we'll get into what happens with A or how A affects the graph later on. But for now, let's just ignore it. Let's say A is 1, okay? Now, if your B is greater than 1, so let's say B is 2, raised to the x power, okay? You get a graph that looks like that. And then let's say you change the base number. Let's say instead of 2, you have 5. Okay, raised to the x power, okay, gives you a graph that kind of, it's sharper, it comes up here, but notice how both of these graphs intersect at 1, okay? And then let's do one more. Let's say we have, instead of 2, let's say we have just 1.5. Okay, 1.5 is still greater than 1, so we still have exponential growth here. So 1.5 raised to the x power. Okay, so notice your equation, oops, let me move these out of the way. So the base number, the 5, the 1.5, and the 2, that just affects the curve, how sharp or how kind of non-sharp the curve is right here. But notice they are all intersecting at 1 here. The reason why is because we said, let's say that our A was 1. Remember that? And so that's what the A does. The A just tells you where your y-intercept is. So on your graph, I just want you to just draw a curve. Just make sure that you are intersecting at 1. Okay, in this case, just draw a curve. I'm not too worried about how sharp it is, but what you need to know is that if your base number here is greater than 1, then it's going to curve up like this. And yes, I know I didn't intersect there. But in this case, for this one, our A value was equal to 1, and that's why the y-intercept was at 1. Okay, so whatever your A value is, that is your y-intercept. Okay, so your y-intercept equals whatever your A value is. Okay, and end behavior, I just want to know on the right side of the graph, what's happening? Is it going to keep on going up forever? And in this case, with exponential functions with a base number that's greater than 1, then yes, it's going to approach positive infinity. Okay, so in fact, the y value is going to approach positive infinity as x approaches positive infinity. And we really haven't talked about this a whole lot. We'll get into it much later in the school year, but for now, I just want to know what this says right here is that on the right side of the graph, as you go this way on the x-axis, your graph is going to keep on going up and up and up and up and up forever. Okay, that's all we need to know. All right, let's look at exponential decay. For exponential decay, you need a base number that's some sort of decimal between 0 and 1. Okay, so let's go back to our tabs, and I'm not going to delete these. I'm just going to change my base number. So instead of 1.5, let's say it's just 0.5. Okay, how does that affect it? Do you see how my graph is suddenly decreasing instead of increasing? And then let's change this x squared to 0.2. Okay, and again, it's curving the opposite way. Let's change this base number of 5. We already did 0.5, so let's try 1/5. Okay, raised to the x power. Let's see, what did oh, where's my blue? Oh, there it is. Why is it not showing? Oh, I know why it's not showing, because 1/5 is equal to 0.2. All right, let's change this 0.2. My goodness, this is really going to kill me. Let's change it to 0.75. Okay, so at least we can see 3 different graphs. Okay, so notice here, your graph can be kind of very casual slope here, or like a really sharp curve here. But again, they're all intersecting when y equals when they're intersecting the y-axis when your y value is 1. Okay, so again, plot your point at y equals 1, and then this time we are decreasing. And notice, let's look back one more time. Notice all these lines, they get closer and closer to the x-axis, but they never go below the x-axis. Okay, so in here again, for this one, we said a was equal to 1, and so that's why our y-intercept is at 1. So your y-intercept is always going to be at whatever your a value is. And then the end behavior on the right side of the graph, as x keeps on approaching positive infinity. Okay, so as you go farther and farther along this graph here, your line, instead of going down to negative infinity, your y value is going to approach or get closer and closer to 0. That's a terrible 0, sorry. To 0. Okay, and so what we're going to find is that there's actually an intercept here, right here. Okay, all right, so get these notes filled in. I know this was a fairly long video, but we will go over the information from this video in class on Thursday and Friday, or we are going to expand upon it. So make sure you have these notes done. If you need to watch the properties again and practice more, go ahead. And then when you come into class on Thursday, be prepared to ask questions and on anything that I didn't clarify well enough. All right, bye.